Okay, so we're starting section 4.2 part 2, but this was a review over 4.2 part 1. So let's see how you did. This is a subtraction problem. So this means we're just going to be combining like terms. So I have to do 3x to the fourth minus 5x to the fourth. What's that going to give us? Right, so that gives us negative 2x to the fourth. And then we're going to have to do negative 6x squared minus, well, we don't have any other like terms for that one. So that's just going to stay the same. Okay, now I really want to put this in descending order, but I'll do that later. Let's just keep going. So now I've got 2 minus 8. Those are like terms. What's that give me? 2 minus 8. Negative 6. So I took care of those, I took care of that, and I took care of this. So I still have this one. So I have to distribute the negative through that one, and I get negative 3x cubed. Now I mentioned descending order though. So I look at my highest exponent, and that's what I want to come first, that term. Then the 3 term, the cubed term would come next, and then the squared term, and then that. And so this is what we get if we subtract all of that. How many got it right? Okay, on number 2, I want you to find the a plus b quantity squared. Here's what people who don't really understand math do. They do a squared and b squared. You can't do that. It's addition. If it had just been like ab squared, if it's just ab squared, that is a squared b squared, because it's multiplication. But if it's addition in there, we have to write it out as a plus b times a plus b. So a times a is a squared, the a times b is ab, b times a is also ab, and then b times b is b squared. So we get a squared, and then if I have ab plus ab, what's that going to be? 2ab, and then plus, and then b squared. So that's what I get for a plus b quantity squared. It's always going to be that. Okay, now I have to do a plus b quantity cubed. Well, I just did a plus b quantity squared, so all I have to do is take this that I already found, and I have to multiply that by another a plus b. This is not just a cubed plus b cubed. If it had been multiplication, like if it had been a times b cubed, that's a cubed b cubed. That's fine. But you cannot do that with this. You have to multiply it all out. So we multiply those and we get a cubed. We multiply those and we get a squared b. Now we have to go to this one. When we multiply those, we get 2a squared b. We have to multiply those, and we get 2ab squared. Multiplying these is going to be ab squared, and multiplying those is b cubed. Now we have to combine like terms. There's no like term on that. A squared b plus 2a squared b is going to give me 3a squared b. 2ab squared plus 1ab squared is going to give me 3ab squared. And then my last term is b cubed. That's my answer. What do you notice about these exponents on the a? What are they doing? Going down by how many every time? So the pattern here is going a cubed, a squared, a, no a. On the b's, no b, b to the first, b to the second, b to the third. That pattern is going to be important with what we do today. Look back here, when we had a plus b to the second. A to the second, a to the first, no a. No b, b to the first, b to the second. Understanding patterns today is going to be what's going to make this easier for you. All right, guys, bring up your notes packet. Hopefully you already downloaded that. If you have not, then go ahead and download it. It's your Google Drive. It's on Canvas. Or this may be a lesson you just want to watch. This, I will tell you up ahead of time, this is one of the more challenging concepts in this unit. People have a hard time with it, so you really want to focus in. All right, so while you're getting that out, I'm just going to tell you a story about how this even came about. Back in the 1600s, there were a lot of famous mathematicians. They worked hard on coming up with patterns and rules for mathematics. So Pascal's triangle is named after a French mathematician from the 1600s. What he noticed is that when we expand a binomial, this certain pattern arises. And he noticed this pattern with these coefficients. So he noticed that anything to the 0 power is always just 1. That's something you have to know. A plus b to the 0 power is just 1. A plus b to the first is just a plus b. A plus b to the second ends up being this. These don't line up perfectly, but they're close. And then a plus b to the third, remember we just did this in the warm-ups? This is what it ended up being. So he noticed all of these rules here. And he wondered, is there some kind of pattern to those numbers, to those coefficients? Look at how he developed this triangle. We start with 1. We bring the 1 down on both sides. We bring the 1 down on both sides. This number here is the sum of these two. We bring down these on the end. What's this number? The sum of what? 1 and 2. See how we bring down the 1? The sum of 1 and 2 is 3. The sum of 2 and 1 is 3, and we bring down this 1. For this row, we bring down the 1, we bring down the 1. What's 4? The sum of what? 1 and 3. 6 is the sum of what? And then this is the sum of these two and that. See the pattern? Can you guys see how it goes? All right, so let's try to do a plus b to the 6th. Here's what to the 5th ends up being. We're going to look at to the 6th. I'm not going to write this part out, but I am going to do the triangle. So I bring down the 1, and I bring down the 1. What do you think would go here? 6. Here. Here. 20. Here. And then the last one would be, and then a 1 there. Okay? So now I can tell you what a plus b to the 6th is without having to multiply it out 6 times. Just listen. It would go 1a to the 6th plus 6a to the 5th b plus 15a to the 4th b squared. Can you guys think of the next one? Plus 20a to the 3rd b to the 3rd, right? Somebody's catching on. Then 15 what? Let's write it out. Okay. So this would be 1 a to the 6th, no b. What's the next one? 6 a to the 5th, what? B plus 15, then what? Okay, don't say the next one. Let everybody look at the pattern. A to the 6th, A to the 5th, A to the 4th, no B, B to the 1st, B to the 2nd. We've done this number, this number, this number, so we're on this one. I need more people figuring out the next term. Anybody new willing to share? Well, what's the next coefficient have to be? I've used 1, I've used 6, I've used 15. What's it have to be? 20. What's A going to have to go to? What power? 3rd. And what's B going to have to go to? 3rd. Okay, then the next term. What's the coefficient on the next term? 15. And then what's it going to have to do? A to the what? 2nd. B to the what? Good. Look at the pattern. You got to think, you guys. Don't just listen to everybody else. A to the 6th, A to the 5th, A to the 4th, A to the 3rd, A to the 2nd. So now we're going to go 16 what? A to the what? Just to the what? 1st. What's B going to go to? The 5th. Okay? And then that last term is going to be plus 1 is my coefficient. What's it going to be? b to the 6th. Good. All right. That's how we would expand a plus b to the 6th. That's what a plus b to the 6th is. It's not like you're going to do this all the time. But on the ACTs, they usually ask you a question like this. And it's something that always shows up on math contests. They'll say, find the fourth term of 3x minus 2y to the 6th. You would not have to do this whole thing. Okay, I just want to do this problem first, even though it's example 3, because I just did to the 6th. The fourth term. Look at your terms. This is term number 1. Term number 2. 3, 4. Which term are we finding? In number 3, the fourth term. So the fourth term is always going to be this. First term, second term, third term, fourth term. So it's 20a cubed b cubed. So 20a cubed b cubed is going to be the fourth term of this. Now, on this problem, what is a going to be? What's in the front here? 3x. B, you have to use the sign and the value. So what's it going to be? Negative 2y. On this term is 20a cubed b cubed. Is that adding or multiplying? Multiplying. So I'm doing 20 times, plug in a, it gets cubed. Plug in b, it gets cubed. Now, just a few minutes ago, I talked about what we do when we're cubing and we're multiplying. This is just 20. What is 3 cubed? So this is going to be 27x cubed. Remember, this is multiplication. What is negative 2 cubed? It is negative 8. But I want to show you something that I see people mess up on the calculator. They'll go to their calculator and they're going to do negative 2 cubed. We happen to get the right answer when we do this on the calculator, but that's not really how you should plug it in. Do you know what you should really use if you're going to do negative 2 raised to a power? Parentheses. Because look, is negative 2 squared negative 4? No. I have to put it in parentheses if I'm going to square it. Negative 2 squared is positive 4. So really, even if I'm doing this, I should put it in parentheses. Just wanted to point that out. So this is negative 8y cubed. When I cube that, cube that, cube that. Okay, now I have to multiply this all together. I have to multiply this times this times this. Okay, so let's do that. I'll just use a calculator. This would be on the calculator part of your test. Another big mistake I see people make is they multiply these and they think they're subtracting this. No, we are multiplying all of this. Is this answer going to be positive or negative when we multiply those numbers? So it's going to be negative 4,320 x cubed y cubed. That's what the fourth term would be if I were to multiply that whole thing out, FOIL it out until I got to the 6th power of it. That's what I would get. All right, guys. What if we now have to find the fourth term of this? Kazuki, what would I have to do if I'm going to find the 4th term and it's to the 7th power? Do I even have a row for my 7th power yet? Could you create it? Okay, tell me how that 7th row is going to go. I'm going to use blue because I'm going to squeeze it in here. It's just for the numbers to start.
1, 7, 21, 35, 35.
Okay, that's really fast. Good. You are correct. Very nice. So I'm supposed to find the 4th term. So what's the coefficient for the 4th term at this level? 35. So I'm going to do 35. Now we have to think about the pattern. Look at the pattern. To the 5th, it goes A to the 5th, A to the 4th, A to the 3rd, A to the 2nd. So for the 7th, how is it going to go? A to the 7th, A to the 6th, A to the what? A to the 4th. So it's going to have to be 35, A to the 4th. B, do you guys know what it is? Cubed. Because what is the sum of these exponents always? We've noticed this with the pattern. 7 in that case. It's always equal to whatever that exponent is. See? 5, 5, 5, 5, 5, 5. For that room. Okay. So now, what is our A value? 2xy. What is our B value? -3. I'd like you to try that on your own. Give me a quick hand raise. You don't have to keep it up, but if you know it, when you know it, give me a quick hand raise. I've only seen, okay, I got 4, 5, 6, 7, 8. All right, Madeline, what do you have? Okay. -7,000, what is it? -7,560 x third y third. Anybody else get that? Seeing some no's. Colin, what did you get? Okay. Anybody else get that answer? Yes, that's what it should be. -15,120 x to the 4th y to the 4th. What you might have done is mixed up your A's and B's or something. Or no, I bet you only cubed this instead of doing it to the 4th. Okay? This is what you should get. How many people did get it? Okay, about 2/3. Good. Okay, guys, we're going to keep working on this. And it's not something that I can just show you example after example and you're going to get. You have to try it. I'm going to do the harder one of these two. Which one do you think's harder, 1 or 2? I will do 2 with you, and then you're going to go back and do 1, and I want 100% of people getting it right. All right, this is to the 5th power. I could sit here and FOIL all day until this bell rings, and I might be able to tell you what this is to the 5th power. Actually, we could do that, but using this pattern will go a lot faster. We already have this one given to us, okay? So we just need to identify what is A and what is B. And I'm just going to be really careful, and I'm going to plug in those values. Okay, so just watch. I'm not going to talk all the way through it. You can kind of be working on it too. Before you go too much further, I want to show you the common mistake. When we have that negative on the B, I think that confuses people, and what do they think of that as instead of multiplication? Subtraction. So here's what I recommend if you have that problem. Circle your terms. All of that goes together. All of this goes together. If you find yourself making that mistake, you're going to want to circle each of the terms. If this is to the 5th power, how many terms do I end up getting? How many terms do I have circled? 6. Okay? Now we're ready to go. What's 2x to the 5th? Okay. Keep on going. We're going to have to do 2 to the 4th and x to the 4th. So that's 16x to the 4th. And what's 5 times negative 5? Yes. Okay, so we're going to get negative 400. Anybody else get that same thing? All right, let's keep going. Just be careful, you guys. What's 2 to the 3rd? I see here people say 6. What is it? 8. So we're going to do 8 times 10 is 80. 80 times 25. Anybody do that in their head or not? 80 times 25? 8 times 25 is 200. Is it 2,000? Okay, thank you. So plus 2,000 x cubed. Okay, let's see this one. What am I going to do here? 4 times, what's this going to be? Okay, now another thing I want to point out. What do you think is going to happen with these signs on all of these? They're going to alternate every time. If B is negative and A is positive, it's going to go positive, negative, positive, negative, positive, negative all the way through. So this is going to be, tell me what it is. Eve and I were just like passing our coffee back and forth. Negative 125 times 4 times 10, right? Negative 5,000, can somebody confirm? Okay. Anybody know negative 5 to the 4th? 5 to the 4th? 625. Something you should know. So it's 625 times 2 times 5. 6250. Don't let me make a mistake on this. And negative 5 to the 5th, I do not know that one. Anybody know it? Or have it? Okay. So 3125. And we have got it. All right, so that's what we get when we do this to the 5th power. Notice the exponents. There should be patterns that you notice. Positive, negative, positive, negative, positive, negative. That's one pattern I notice. To the 5th, to the 4th, to the 3rd, to the 2nd, to the 1st, no X. That's another pattern. There should always be patterns within these. Okay, guys, try this one on your own. I'll be doing it up here. We'll see if we get the same answer. Check my math. I tried doing it without a calculator. Hopefully it's all right. How'd you do? All right, guys. So again, we could take these numbers all the way out to infinity. This pattern holds true all the way out. So you're going to have a worksheet to do where I'm going to ask you to write Pascal's triangle out to the 10th level. Pascal's triangle is just telling us the coefficients. You do not have to write all of this out. I just want you to come up with those coefficient values. Yeah, Jackson? Sure. Okay? Makes sense to everybody? It's not difficult, but you can see, like, you just got to practice doing it. And then it's going to get super easy after you do about 3 or 4 problems.